So, welcome to my talk. Dive into VR with WebGL and Three.js. Got the address again. Here we go. So, who am I? I'm Chaz Wilson. I'm from San Jose, California. And let's see, I'm interested in different cultures and languages as well as technology. And because of my interest in culture and language, I'm here in Japan. And I've been here for 10 years, a long time. I can speak Japanese, I can read it, can't write Japanese well, but work on that someday. Here we go. So this is my outline. So first off, why am I interested in Three.js? Where Three.js is being used, a quick intro to Three.js, what it is. Then we'll go back, kind of step back a bit and go into 3D basics, just basic terminology which will help you understand things a bit. Then we'll talk about Three.js and WebGL. So and we'll explain to you what WebGL is. And then we'll talk about Three.js, shapes, materials, lights, and cameras. And at the end, there'll be a little code along, which is why I hope you have a laptop or sitting next to someone who does. Good, thank you. Okay, so first, why am I interested in Three.js? I had a good experience using a different framework, which was A-Frame. I hope you saw Ian's talk about A-Frame. But I wanted to work with something a little bit lower level, and WebGL is like too low level. So I'll show you what I did before. So I made this little app, and it animates text, and you can move things around and change parameters, and it's exciting. But there's some problems with it due to it using A-Frame stuff. But anyway, you can see all that. All right, I'm going to close that. All right. So where is Three.js being used? Google has a site called poly.google.com, which hosts 3D shapes. There's also React 360, which is Facebook's 360 project, and A-Frame uses Three.js as well. Oops, sorry. There we go. Okay, so I'm going to show you some examples of sites that use Three.js. And one is this one made by people at Google, and this other is a tribute to Jay Dilla. So, here we go. All right, so this site was made using Three.js, and it's just about small arms sales of all things. But I felt it used 3D in a novel way, and to present data. You can click on different countries, see how many weapons they're selling, where they're coming, where they're flowing. And what I liked about this website as well is it's using a lot of basic shapes, simple shapes. Three.js is capable of having models loaded into it, but today I'm presenting basic shapes. So here you see a giant sphere, there's small little particle effects, so we'll talk more about things like that. And then, here we go, here's another one that uses effects, basic shapes to create different effects. And so this is a tribute to Jay Dilla, and this was all done in Three.js. And I should point out that it's being rendered on my computer right now in real time. Okay, so next. And if you want more examples of what Three.js can do, go to Three.js.org. This is their homepage, and it's full of examples right down the front page. Next, so why use Three.js or 3D in general? 3D makes a website look polished and interesting. Also, 3D can be used to distract users from things like long loading times, maybe there isn't enough data, the data's coming in too slowly, you have some little 3D toy they can play with, and they forget that your website is slow. Also, 3D as a user experience is really good for exploration. Like VR is an obvious extension of that. But if you want a different experience, rather than having a list where everything's organized and logical, maybe you want to explore. And a good example of that is maybe a music application on a cell phone. You can scroll, you can see the album art, you don't really know what song you want to listen to. You see the pictures, you think about how you feel, and then you choose a song. So 3D is quite good for that sort of thing. Okay, so 3D basics, really quick. 3Ds have the most basic thing there is what's called a vertex. It's just a simple point. And then the plural is vertices. So here you can see the vertices of this shape here. Between vertices, you have what's called a line or an edge. And here, all the lines are connected to each other, to each vertices. Then you have a face, and that is just a simple triangle. Generally, modern 3D renders all use triangles as their basic shape. You put faces together and you form a polygon. So a polygon is just a flat surface. And it's multiple triangles pieced together to form a plane. If you link those together, they become a surface. And then you put those together and you get your final object. Okay. So let's step back a second. What exactly is Three.js? It's a high-level 3D API for web pages. So high level means that you don't have to think about the minutia of how 3D is working. If you use OpenGL, you have to think about each point. And with Three.js, you don't. It was originally written for Adobe ActionScript, and it was ported to JavaScript and released on GitHub in 2010. And in 2011, WebGL came out, and the render was ported to that. And it is built on WebGL. So, what is WebGL? WebGL is the low-level library for 2D and 3D graphics built into a web browser. This means it requires no extensions to run. And if you remember back in the day, in the 90s, if you wanted to have 3D, or in the early 2000s, if you wanted to have 3D or animation, you needed a plugin. Well, now you don't because of WebGL. WebGL provides accelerated graphics and also physics simulations and image processing, and some of the libraries used for performance processing in other areas. Okay, it's widely supported. All your browsers are here. So how do you use WebGL? First, you start with the canvas. So this is an element in the document object model. And at the end of the presentation, we'll go into that in more detail. But basically, instead of an image tag, if you're familiar with web pages, use a canvas tag. And the canvas tag doesn't do anything. It just gives you a place to put your images. And I'll show you how that's done at the end. Okay, so the canvas is a container for graphics. It has no drawing capabilities, and you can use get context or drawing. Let's see. So this is what code would look like for 2D drawing in Canvas. And all this code would get you just a black box, which is very interesting. And if you want to use WebGL, it's very similar, and you get the same black box. All right, so what do 3D objects look like in WebGL? Well, this is what the code looks like, and it's very detailed. And if I could keep extending it, it would probably go all the way to the floor. And all that code would get you this, except it would spin. So you get a spinning cube, and you get about 5 pages of text to get that. So that's what WebGL is. So let's look at geometry in Three.js. Here's your basic cube in Three.js. It doesn't spin, all the sides are the same color, but you can see that it's much simpler how you create this cube. All right, so what's the primary advantage of Three.js over WebGL? Let's see, Three.js has a library of shapes and materials. So in WebGL, you have to basically define what a cube is. In Three.js, you just have to say, what makes my cube or my shape or my material unique? You don't have to define your material from the basics. All right, and so this means it's faster to develop on. All right, so now I'm going to show you the built-in shapes. Go. So built-in shapes demo. Oh, that's not it. Here we go. All right, so this is the first shape. And what this is called box geometry. They used to call it cube geometry, but you can make boxes of any dimensions, not just cubes. And you'll notice here you have the wireframe on it, and you can see how the cube is made up of triangles. All right, so these vertices are connected to each other, forming triangles, and you get your cube. All right, this is a sphere. And if you look at the edge, you can kind of see it warbling. And this sphere is relatively low resolution. It has a low polygon count. Now I'm going to increase the polygon count here, and you can start to see it get more and more rounded. And this takes more processing power, but gives you a better sphere. And I continue that, And eventually you get a sphere that it doesn't even look like it's moving anymore. Whereas if you go back here, it's pretty obvious. All right, next you have a cone shape. And again, low poly count or high polygon count. And a cylinder. And the interesting thing about a cylinder is you can define the top and bottom radius. So they can be different sizes, so you don't just create like a soda can or a pipe shape. You can make bases or whatever you want. All right, this is plane geometry. So these are flat. And what's interesting about these is by default, they're one-sided. And you can add a tag to make them two-sided. And here you can see a flat square plane is made up of two triangles. All right, circle geometry. Here again, you can count the sides. This is the default number of polygons. But if you increase it, you'll get more or less a round shape. And you can keep increasing it, but it costs more on the CPU, or it costs more processing power on the CPU. All right, there's a ring. The ring, you can also say where it starts and stops. And a lot of the shapes have this option, so you can make more interesting shapes than just a simple ring. You can kind of make these curved shapes. You can make half cones. You can make half spheres, those sorts of things. All right, tetrahedrons. We have some funny shapes here. All right, we'll go through this real quick. Torus geometry, this just makes rings, three-dimensional tube rings. At low resolution, it's a hexagon. You increase the resolution, and it becomes more ring-like. All right, this is a torus knot. I think it's the most interesting basic shape in 3.js. And you can modify the parameters, and you can get all sorts of different effects. And you can change the materials, make it more interesting. There. And all this is made with just changing a few numbers. And I'll show you how that's done in the last part. Okay. So built-in shapes demo. Moving on. So there's a few more shapes. Actually, there's quite a few more, but there's a couple more that are interesting. You have shape geometry. So you define the points and then how they're connected, and then you can build any shape you want, any flat shape. There's extrude geometry, which lets you do a beveling effect. I didn't implement this in my program, but it's kind of useful. And there's text geometry, which I used in that first demo you saw where the text was flying. That was from the Three.js library. Okay, and tube geometry. This one's interesting. You just define the points in the tube, and then you define the number of segments, the radius, and the radial segments here. Okay, so materials. So all those shapes are just shapes. They don't have a material. They don't have any instructions on how to reflect light. And that's where materials come in. So the basic materials in Three.js are the basic material. And the basic material doesn't reflect light in a natural way. It's two-dimensional. There's a Lambert material, which is more of a flat, diffused material. You can see that it doesn't really have any highlighting. Then there's the mesh Phong material here, and you can see that dot there. That's the highlighting. And there's one more material, it's not in this diagram, which is called the mesh standard material. And that blends Lambert and mesh Phong materials. So you're able to kind of define how diffuse and flat and how shiny it is simultaneously. And the last one's the normal material, and this has to do with the angle of light coming off of it. Okay, so materials demo. All right, let's get an interesting shape. And here we go. So this is the mesh basic material. And as you can see, it's just one-dimensional. And they're all gray shapes. You could have other colors, but you only see a silhouette. This is the same material, but added with an image added on top. Again, not very interesting. Then we get to the Lambert material. You can see light reflecting on it. Here, I'll add a light to the scene. Okay, actually, here's the basic. The light's still on, but with basic, you can't see the reflections. With the Lambert, you can. Okay. And then the next material, this is Lambert with with an image on top of it here. And let's change it to, this is the mesh fong material, and this is going to have brighter highlights, and I'll get a sphere here. So you can see that. Well, you can see it here, in particular, on this shape here. You can see two of the lights that aren't moving, how it's getting a white dot, and that's kind of what the mesh fong material does. Here you can see it. All right, and this is mesh fong with the same normal mapping, the same image placed on top of it, but it has a very different effect. Okay, and this is the standard material, which is the blend of the last two materials, the Lambert material and the mesh fong material. So there should be some highlighting, but also it looks smooth and flat. So there's less highlighting, but it's possible to change these parameters to make it more metallic looking or have a rougher surface. Okay. And this is the last one. This is mesh standard with an image on top and some normal mapping, which okay, and the last material, this is the mesh normal material. And this is a really strange one. It has to do with the angle of light. So the top is flat, and that's why it's all one color. And then across, you can see this gradient because it's coming out at different angles. If you can imagine like spokes coming out of this if you're into math, like at a tangent. See, yeah, so these are those shapes from before. Again, so it's the angle of light that gives it its different colors. Right. Here we go. So shaders. I didn't implement shaders in my program because they're really difficult. You actually have to learn what's called OpenGL shading language. So there's a whole language you have to learn just to make shaders. And I didn't learn that. And then once you write something in this language, it's compiled into WebGL for the GPU. And there's primarily two types of shaders, a vertex shader. And if you remember, a vertex is a name for a point in 3D. And then there's a fragment shader. And this fragment shader has more to do with light, and vertex shader has to do with where those little dots are. And the rule, as I understand it, is a vertex shader can modify where a point is in your image, but it can't add or subtract points. It can just move them around. All right, and shaders are used to implement effects, not in materials. So what that means is like, if you want to create a property that's not possible simply by bouncing light off of something, or you want to have light bounce off in a weird, unnatural way, you can do that with a shader. And I'll show you some demos of a shader now. So there's a really good site called shadertoy.com, and these are all different shaders. So they're using combinations of vertex shaders and fragment shaders to create these effects. This heart, like that would be a vertex shader. This looks more like a fragment shader. And this one's cool. And this again, so the movement is being controlled by a shader. So a shader just allows you to add different visual effects in your pipeline. All right. So moving on to lights, all right? Because without lights, you really can't see anything. So here we go. So there are three basic bands of visible light. And unless you're colorblind, you can see red, green, or blue. Red, green, and blue, and colors in between, sort of. So the color we see the most about, interestingly enough, is green. They think it's because when we were in jungles or our ancestors wanted to see differences in green, because like an animal could jump out at you, basically. So if you can see the difference in green, it helps you out. The next color we can see is red. And then the one we see the worst is blue. So blue is the weakest light as far as our eyes are concerned. All right, so light sources such as these lights here emit different ratios of RGB bands. So these lights here probably are pretty even. I think fluorescent lights tend to be a little greenish, right? So there's maybe a little extra green in there, but that's more or less how lights work. We don't have any other lights in the room that I can point to, but anyway, different lighting sources emit different ratios of these bands. And different objects, and particularly materials on the surface of those objects reflect those ratios differently. So what makes something red is how it's reflecting light, right? And so what's great about Three.js is it does all the calculations for us. So you don't have to be concerned with how a light source reflects off and the angle of reflection and all that math. You just give it the color of your light, you give it the color and the type of material it's reflecting off of, and it takes care of the rest for you. So that's really important. Okay, so I'll show you some lights in Three.js. Okay. All right, so let's see. Standard. Here we go. Okay, so the light is right there. So this is the point light. The first light I'll show off is the point light. And the point light is a light coming from a source. If you can imagine, not that the sun's not a good example, but an exposed light bulb is a point light. It takes light coming from a point in space and going in all directions. That's what a point light is. And here, that green dot represents the position of the point light. But lights in Three.js and 3D applications, you can't see them in the camera. You can only see them in reflections. So that green dot I just put there so you can see where the light is coming from. That's not the light itself. But the light is in the same position. Just happens to be followed by a green dot. All right, and as you can see, the point light has a target, and that's important. And this is a really cool thing Three.js does for you. The cameras and the lights, you can assign them a target, and then they face that target. Okay? And that's going to be important in this next one here. Oh, sorry. Lights. There we go. Okay, this is the directional light, and this is where that target becomes important. So the light coming from this green dot here is aimed at this sphere in the middle. And the directional light, if you see, it's not hitting the ones on the side as much. Okay, and as it follows around, and this is a directional light. And a directional light would be like a light inside some sort of holder. Okay, it's kind of aimed at something. Okay. And next, this is the spotlight. And now a spotlight is a directional light, but even more focused. And so you can see it's not lighting up these spheres in the back until you can imagine that points back here. And if it's aimed here, it's going to hit this guy. And if the point of light is over here, it's going to hit this sphere here. So the light's over here now, it's kind of moving around, and that's where it's hitting it, and then it's going off of them. And you can also see the shape of the light. You can actually see that it's kind of a circle. Even if these weren't rounded objects, you would actually see the edge. So it's a very sharp, focused light. All right. Oops. Next. Okay, so they're back to point light. Good. Okay. There's a couple other lights that I don't have in my demo. One is the atmospheric light. And the atmospheric light, take here, is the light that just lights up this whole scene evenly. Ambient light, not atmospheric light. Ambient light lights up the whole scene evenly. What's interesting about ambient light is it doesn't have any direction or source. Unlike the natural world, like all lights have a source, ambient light in 3D is just everywhere at once. So it's kind of magical. All right, and then there's a variation of ambient light, which is called the hemisphere light. And what's cool about this one is you can have one color coming from the top in all directions, and one color coming from the bottom in all directions, and they can be different colors. And in the natural world, you'll see this a lot. You have the light coming from the sun that's pretty even across all bands, so it's white light. It hits the surface, the ground, and the color of the ground bounces up, right? And you can see that in this picture here. So you can imagine kind of a bluish or white light hitting the top of this flamingo. And that's the color you can see up here on the top of its wings, on the top of its body and its neck. And then they chose a different color for the bottom, and it just happens to be the same color as the sand to mimic what light would do when it hits this sand here. It'd make it orangish. And you can see the orangish light here on the bottom. If that makes sense. And at the end in the demo, I will use the hemisphere light to do the code along. All right. Next. So last, and very most importantly, is the camera. All right? So the camera, it's the virtual eye. Now, there are two main types of cameras. There are actually a couple of variations of them. But there's two main types that are really important to understand for Three.js. There's one that's called the perspective camera. And a perspective camera is how you see things in the natural world right now, or with a normal camera. Pretty much outside of computers, everything's pretty much a perspective camera as far as I know. And that is a perspective camera, as things get further away from you, they get smaller. And as they get closer, they get bigger. And that's how we perceive the world, right? And that's how cameras take photos, and things far away are small, and things that are close are big. But there's another camera. It's called an orthographic camera. And this one, everything is the same size. So regardless of distance, it's the same size. And I have a picture of that for you. Here's a game with orthographic projection. Hopefully you played a game like this, or the SimCity 2000 or something similar, Diablo, or those kind of games. And you'll notice that like the buildings are the same size, regardless of where they are in the picture. The ones in the bottom of the frame are the same size as the ones in the top. And that's an orthographic camera. All right, so camera demo. All right, so this is perspective camera. Right? Now if I click this is what orthographic camera looks like. And see this motion here. All right, so the camera actually is what's moving, not the objects. And now I'll show you the same animation from perspective. So you can't see these other two boxes until they kind of fly in at the end. But you also notice they're smaller, substantially smaller. The two boxes in the back. When you switch to orthographic camera, sorry, they are the same size. And that's true for all the shapes. All right. Along. Okay. This brings us to the code along. So who has a laptop? Can I see a show of hands? I got four people. Okay. Five. A couple shy people there. Okay, that's pretty good actually. That's like 1 in 3. If you don't have a laptop, maybe shoulder surf, please look over the shoulder of somebody nearby and try to follow along. Please go to github.com /Chaz303 sorry about this name, Three.js-tech-talk. If you get as far as my name, you can hopefully find this. Everyone on the laptop who wants to participate have these files? Bo, you're good? Okay, Bo's good. Ian, you're good? Okay. People I don't know. Your name? How are you feeling? Okay. We'll move along. All right, so getting started. So this is what a basic This is what a basic web page looks like, okay, an HTML document. So if you're not familiar with this, we'll just go over the parts really quick. Between the brackets at the top, it says what type of file it is. Next, you see this, it says HTML, and at the bottom it says HTML. And everything between those two tags is HTML, more or less. Then there's the head tag, and this is where your title is going to go. And that's what the title you see in the top of the bar in your web page. And you can also have, here we put some styling elements. Often, these are the same codes that you would use in CSS, except for simplicity, I put them in the same file, so we didn't have to worry about getting different files on the computer. So that's here. And then you have the body, and this is where the text that you see inside your web page resides. Your text and your images and all that. Most of the web page actually resides here. And this is the part we're going to fill out. All right? And here you can see the canvas that I mentioned at the beginning. And the ID is my canvas, and that'll be important in a second. And then the script. Normally you would have this on the same server, but because of browser security reasons, it's better for it to be hosted on a website. So I'm using this here. All right, so in the second file, index-2.html, put in the script. And this script, here we have const scene, so we're setting up the scene. And the scene is where everything in Three.js is going to go. Your cameras, your shapes, your materials, your lights, all those things are going to go in a scene. And that's here. And it's a constructor. Here you have an object constructor to make that scene. And next we have a camera. We need a camera to see. If you don't have a camera, Three.js doesn't have output. Like that's visible. So you need a camera right here. And again, you use an object constructor to create a camera. And it's a perspective camera. So we all know what that means now, I hope. It's just a normal camera. All right? And 75 is the number of degrees vertically that the camera is going to show. And then this is the ratio of the image. And it's the inner width of the window divided by the inner height. These last two numbers are kind of interesting. This is how close the closest object that it's going to show is. And this is how far the furthest object is that Three.js is going to render or make. Anything outside of that, it'll keep track of its place, but it's not going to show it on the screen. Okay, and anything less than this number, it won't be shown either. All right, so moving along to index-3.html. Real quick, we need a light. If you don't have a light, unless it's, well, a basic material, you can't see anything. So here we create a light. Again, we use an object constructor method with JavaScript to create a new light. This is the hemisphere light, and I thought that's an interesting one because it has the two colors. And here you have the colors in what's hexadecimal here. And so it's 0x and then followed by hexadecimal code for the top light and then the bottom light. And if there was a third number here, I don't know if it's in your code or not. Maybe I forgot to update my slide. If you see a third number, that's the intensity. All right, and then scene.add. This is taking that scene that we created at the beginning and we're putting the light in the scene. Okay. So file number 4. Here we are, we're creating a material and a shape and its material. You need both in order to see something in Three.js. So we create the shape, it's called a geometry. And we have, again, the constructor to create a box geometry. And we're giving it, because it's a box, it has X, Y, and Z dimensions. And they're given here. Okay. And then next is the material. And this is the mesh standard material, which is kind of the blend of the Lambert and Phong materials. So the one that's kind of good at diffused, kind of like diffuse, it has diffuse properties and those kind of bright, like the Phong reflectivity to it. And let's see, and then the last thing is the shape. Here we are actually creating, in Three.js terminology, is called a mesh, and that's when you bring the geometry and the material together. Okay, so a geometry without material you can't really see, and a material without geometry you can't see. So you need both together inside a shape or a mesh in order to have an object that's visible, and then you need to add it to the scene. Scene.add this shape. And then the last thing I did, I moved the camera. Should have put that in this prior one. But anyway, move the camera 30. Because everything in Three.js by default is going to be at 0.000. So on the X, Y, and Z axis, it's going to be in the very middle. Except for some lights are actually slightly plus on the Y. But otherwise, they're in the middle of the 3D environment. So move the camera in order to be able to see anything. Otherwise, the camera, the lights, everything will just be on top of each other, and you can't see anything. So that's important. All right, so this is the last step. We're going to add the renderer. So this is what's going to compute all the lighting, all the geometry for you. So you have to create a renderer here. And let's see, then you have to give it the canvas. So I'm assigning it to that canvas element from before. And then let's see, and I have anti-aliasing equal true. Actually, I assigned it twice. Anti-aliasing to be true, that makes it smoother. And then renderer set size, this is what matches the resolution of the renderer to the size of your browser, right here. All right, and then there's one more thing here. It's creating an animate function. And this is an interesting piece of JavaScript right here. Request animation frame. And this works at the browser's frame rate, which is typically 60 frames per second. And it takes a callback, which is the same as the function. So the function is calling itself repeatedly. It's known as callback. And inside that function, I'm going to move the shape on the x-axis 0.01. And then I'm going to move it on the y-axis 0.01. And then the last thing is just render the scene with the camera, and then animate. And then here, this is outside the function. Animate is called. This is the first time it's called in the code. And then once it's called, it's going to keep calling itself. And it's going to form basically an infinite loop. And inside that loop is going to be your animation. All right, is that clear? Because now I have questions. So if you could open index-6.html. If you're following along, so I can open it here. There's hopefully you have something that looks like this. No, you shouldn't have anything that looks like this. I'm sorry, I opened the wrong file. You should have something that looks like this. All right. Does that look familiar to people with computers? Yeah? Okay, good. So this is the file, and this is its output in the browser. So people with computers, do you have this? Yes? Yes? Good? All right, so I have some questions for you, if you've been following along, and maybe think about it, and I'll give you some guidance here. So if you're looking down here, I suggest you look at this part where it says call render and animate. All right. My first question was, how do you think you can make the cube rotate faster or slower? How do you think you can make the cube rotate faster or slower?
Increasing the
cool.
Just increasing the increment of the rotation x and y axis.
Right. So yeah, just by increasing this number here, I'll make it 3 times as fast, which is pretty nuts, I guess. Let's see. Save that. Reload this window. That's 3. That's kind of subtle. Let's get rid of this 0 here. Let's make it 30 times as fast as it was. So it should just be flipping around and being all sorts of confusing. Let's see. Yeah. Okay. So that's it. So you're increasing the amount of movement that happens in the frame, and that's in a 60th of a second. And I'm going to stop that. Okay. Save. Okay. Good. Next. So the next question, let's see. How do you make the cube rotate along an additional axis? So right now it's rotating on the x-axis and the y-axis. How would you make it rotate on the z-axis?
Adding a new axis.
Okay.
The shape of rotation.
Right. So all you would do is you would maybe copy one of these, like this. Paste it here. And then you would replace y with z. And save that. And it should, well, I'll make it even more obvious. Comment out these lines. So now it's only going to rotate on that one axis. So, okay. And then I can put all this together. Okay, so now it's rotating on 3 axes. Okay. So how do you change the color of the light? Any ideas on how you would change the color of the light? There's the hemisphere light. And for those who don't have screens, so the light is up here.
Changing the first 2 parameters. Color, code. I think so. Yeah.
Right there. Okay, so everything after the 0x, and for people who aren't familiar with web design, I'll explain this really quick. You have hexadecimal. So hexadecimal runs 0 through F. So it goes 1 through 16. So you get 1 through 16, and for each decimal, for each place here, and 2 of those for each color, and they go in the order red, green, blue. So FF is the amount of red, the next FF is the amount of green, and the last FF here is the amount of blue, and this is coming from the top. And then the same pattern coming from the bottom. All right, so there's a lot of red and green here. FF is the maximum amount you can have. And 3.3 is pretty low.
Yeah. What's the third argument here?
Oh, the third argument. Yeah, I forgot to add it to the slide, but this is the intensity.
Okay.
So if I can show that to you really quick. I can bleach out the thing. Right here, just reload.
Wow.
So right, if you make it maximum intensity, it's just going to be completely white. Good question. All right, I'll put that back down to 2 or something so you can see. All right, and if you wanted to change the color, how would I make this, somebody who hasn't answered before, how would I make this blue? Like completely blue? Anybody know? Okay, that's right. So let's see, so 0, 0, 0. F, I'll make the sky blue, I guess. Actually, maybe it's sitting above the water, so here. 1, 2, 3, 4, right?
0, 0, FF 0. Oh, yeah, you're right.
Okay, no worries.
That makes sense.
Okay, that's right. So, right, so the light coming up from the bottom now is completely blue. And if I want to make the light from the top completely red, do that here, it's going to be only red. Right, because there's FF, maximum red, and then 0, minimum, nothing, right? So this should be red on top and blue on bottom. Let's see. Right, and so on the angles you're getting purple because it's getting both. Let's see, what other questions do I have? How am I on time? Okay, good. Let's see, one more question. Let's see. How would you make the cube larger or smaller? Actually, I encourage you to try this. Just you get some interesting results. So making the cube larger or smaller? So if I just do shape.scale.x, what do you think will happen? Anybody?
Somebody bigger on the x-axis.
That's right. And the rest will stay the same. So let's do that. 0.03, I guess. Let's see. That was a little fast. But we can change that. Here. Let's make that change to 1. See that? It's getting larger on the axis. Then you can make that now. Right, and if you want to make it get large in all dimensions, you would just add shape.scale.y, shape.scale.z, and have them increase by the same amount. All right, and I have lots of questions, but no time for answers. Anyway, do you guys have any questions for me? I think we're kind of at that point. Yes?
Do you have an idea why it's the convention to use straight lines and no curves?
Straight lines and no curves for what?
Like in a lot of like vector artwork, you can describe a curve. Why is that not the case with this? Any idea?
Oh, okay. Why is that not the case? Well, the basic shapes. They're primarily focusing on like tools that would you could kind of building blocks. I mean, there is a curve shape here, and there's the torus, which is here, and you can make this torus in art as well. And there is that other material. Let's see, the thing that makes the tubes.
Yeah.
So those exist, but generally anything with curves in 3D is expensive for the CPU because it requires a lot more polygons.
Okay.
So that's why you see it's easy to have a bunch of cubes because it's just a few flat surfaces. Each flat surface on a cube is only 2 triangles, whereas to make, let's see, go back to a sphere, my high resolution sphere. There we go. If you look here, each one of there's so many it's actually difficult to see, but I can go lower resolution. Well, you can see how many triangles there are, and it just keeps increasing, and that would be more taxing on your CPU.
Okay.
Any other questions?
I want to know things like, can you run Three.js on hybrid apps or things like React Native, or like you need some special hardware to support the devices?
Okay, that's a good question. Anything that supports WebGL supports Three.js, and in some mobile platforms do. I know you can use Three.js with React, but as far as React Native, I imagine you can, but I haven't done anything with that.
And the other thing, is it using the browser's engine capabilities, or like your device or like machines?
Machines. Okay, so wow. Okay, so WebGL is basically giving the browser access to what's called OpenGL. Okay, but it has a different security model. I'm kind of gonna get out of my element really quick here, but basically, like OpenGL is like run on your computer. It's considered trusted code, whereas any code you get from the internet can't be trusted, more or less. And so there's more like kind of restrictions on what you can do. Any more questions? All right. Well, thank you very much.